The final key to the puzzle comes, as we'll see later, when the discoveries of molecular biology and the ideas of genetics come together to finally give the Darwinians something upon which natural selection can act, the gene. As we'll see later, the gene becomes, by the middle of the 20th century, the object upon which natural selection can exert its force. Now, suddenly, the idea of natural selection being a force in the Newtonian sense has more of a reality, because there is a physical object in the world upon which that force can act. Now, what has been happening to physics all this time? Well, let's go back to the 19th century. Here we had Newtonian physics reaching its pinnacle. There were Newtonian physicists who believed that if you could predict the motion of every particle in the universe, you could then tell the future, the entire future of the universe from that. Everything was seen to be incredibly deterministic, meaning that the theoretical basis of physics was so strong, was so powerful as a predictive force, that you could actually think that everything about the world was determined. It was clockwork in its functioning. As a result, 19th century physics was such that it was clear that everything was answered. There were physicists who, by the end of the 19th century, were saying, we have no more experiments to do. We know everything there is to know, and we're now just filling in the holes that are in our knowledge. A few more experiments, and we'll now know everything there is to know about nature. What they didn't realize was the revolution that was about to come at the beginning of the 20th century. And that revolution was brought about by those young physicists, all of them actually in their early 20s, who invented two things: the theory of relativity, Albert Einstein, and quantum physics, Niels Bohr, Fermi, and the others. It was the advent of quantum physics and relativity that completely upset the apple cart, because now we have the great principle of quantum physics called uncertainty. The principle put forward first by Heisenberg, one of the early developers of quantum physics, which said that not that our errors in observation are simply a question of being better experimentalists, but that there was a fundamental uncertainty in our ability to know about the world, a fundamental uncertainty. Now, that uncertainty, true, is really in physics calculated at the subatomic and atomic level. But nonetheless, the pattern of thinking now of scientists is such that the uncertainty in observation is seen not as a lack of precision, but as a fundamental property of our way of knowing the physical world. This changes completely the philosophical underpinnings of physics forever, at least for the present, we'll say, until the next revolution happens. Now, physics isn't seen anymore as the deterministic kind of science that it was seen in the 19th century. Now, physics is seen as only a description of the physical world that is as good as uncertainty allows it to be. In addition, quantum mechanics now has a series of paradoxes that are raised about the physical world. Things that happen in the physical world that can't simply be explained easily by the theory. Things like the Schrodinger's cat problem, which I'll come back to in our last lecture when we talk about some of these issues. Things like the interaction between particles which start together, and after they are feet or yards or miles or galaxies apart, are still communicating with each other instantaneously. Paradoxes which tell us that everything we see in the natural world is one giant interacting system, that we can't really understand the problems of that are raised by the physical world by reducing it to the problem of one particle. That one particle must interact with another, and as soon as we argue that, we have a system of interactions rather than one particle. So the philosophical basis of science, as far as physics is concerned, now includes uncertainty, and it includes complexity. It includes systems interacting. What does that do for physics? Well, it throws out some of the older philosophical approaches. The logical positivism of the 19th century runs headlong into this and essentially disproves itself by the middle of this century. It tries to show that mathematics and logic are related in a way that isn't true, and basically proves itself out of existence as a philosophical basis, and physics actually now has no what anybody would call really sound philosophical basis. It's sitting there with quantum mechanics at its center.